Saxon Advanced Mathematics, lesson 95. This is a fun lesson. It's very quick, to the point. It's two problems. We have talked before about finding the complex roots or the roots of complex numbers. I'll remind you of the process because it's been a while, but the process isn't changing. The only thing that is making these advanced is that the numbers just aren't going to work out as easily, and we'll need to use a calculator to find them. But no big, right? Grab your calculator. If you don't have it, pause me, go find it. And let me remind you of how complex roots work. The first thing I want to remind you is that to find complex roots, we have to work in polar form of the number. So let me write that down. Okay, to find complex roots, use the polar form of the number. All right, now I know what you're saying. I know what you're saying. I would be saying it too. What is the polar form of the number again? Okay, well, let me go back a step and remind you of what the polar form of a real number looks like. That's the thing where we go, we have a number here, and then we have the little box thing, and we have an angle inside of it. This is the hypotenuse. And this, excuse me, this is the measure of the angle, right? And sometimes we say direction and distance. There's different ways we can describe it, but this is the most literal interpretation. This is the hypotenuse of the angle or the triangle, and this is the angle that we go to find it. Okay, now that's when we're doing polar form of a real number. When we're doing polar form of a complex number, we write it slightly differently. We use this cis thing, remember, which stands for m times the cosine of the angle plus I times the sine of the angle. This is like a shortcut. It works exactly like this. M is still the hypotenuse, n is still the angle. We just use this notation instead of this one to remind us that one is a complex number and one is a real number. Okay, so we'll be trying to get our numbers into this form. So let me just look and see if there's anything else I want to tell you before we begin. You don't see this, but all around me when I'm teaching you, I have all kinds of papers and notes. My book is open. Got all kinds of stuff going on here that I'm drawing from to make sure I give you the best information in the right order. Okay, so what we're going to do, let's start the first problem. This we'll remember. So let's look at an exact problem. That's what I wanted to, that's enough to get your bearings. Example 95.1. What John wants us to do is find 4 fourth roots of 6 plus 4i. Of 6 plus 4i. And then we know the first thing we want to do is change that into its polar form, right? Where this is the hypotenuse and this is the angle. Okay, so we remember we draw the triangle. And this is the x-axis and this is the y-axis, right? Since it's complex number, we call it the real axis and the imaginary axis, whatever, it's the same thing. And we can quickly see this is gonna be in the first quadrant, right? Because it's positive and positive. So I'm gonna draw just the first quadrant angle, and I'm gonna just approximate these. It's 6 on the real axis, and it's 4 on the imaginary axis. I put my dot right there, and then I draw my hypotenuse up and drop it down to the real axis, in this case, the horizontal, right? That's how we always draw triangles. Now I know these numbers are gonna be the two sides, right? This will be 6 and this will be 4. I don't have to worry about the I, that's just telling me which axis to use. Okay, so now we have a triangle. Now we find the hypotenuse and the angle. So I'm gonna call this H and I'm gonna call this theta. Okay, let's do the hypotenuse first. To find the hypotenuse, the way most students prefer to do it is using Pythagorean theorem, right? And we know that it will be the square, I can make it equals. It will be the square root of 4 squared plus 6 squared. These are the two legs. This is the hypotenuse. This is a squared and b squared. And what I've done is instead of having c squared here, I took the square root and I'm calling this just c. This is just Pythagorean rearranged, and I hope by now that looks fine to you. Okay, so let's see. This is going to be 16 plus 36, right? And then we can say that the hypotenuse equals the square root of 52. And then we can use a calculator to get that as a decimal number. We don't want to use it unsimplified. In this problem, we're going to need that as a decimal number. So go ahead, use your calculator. You can use the square root key. I think it's an X here. Remember, this is my little notation that means it's a calculator button, those like rounded corners. I know, it's my icon. You can use this function, just enter into your calculator 52, hit that, and what you should get is a hypotenuse of 7.21. All right, so now I can take this number and fill it in right here, 7.21. That's my hypotenuse. All right, now we need to find the size of this angle. The best way to find the angle is to remember that the tangent of this angle will be equal to, tangent is over Arthur, so it's opposite over adjacent. It is 4 over 6. All right, so the way that you enter this into the calculator is to go, I'll make it a long line, 4 divided by 6 equals, and then second inverse tangent, and then I think you might have to do one more equals. You might get the answer just after you press that, but all of these are entries onto your calculator. Since I am using my camera to film, I have to draw fake calculator buttons on my page. Remember, this is the one that we use when we know the decimal and we want the degrees. All right, this is the function that gives us this. And we do know the decimal, we saw it as a fraction, but 4 over 6, right? We changed that into a decimal right there. And we get the angle, and what we find is that theta equals 33.69. And that is in degrees. Okay, so the next thing we have to do is look at our picture and see, do we have to adjust this at all? You know, when our triangle flops around to different quadrants. we sometimes have to adjust because we're measuring from here going back, right? So sometimes we have to do adjustments to that. But here in the first quadrant, it's easy. 33.69 is this angle right here. And that's exactly the way we want it for our polar coordinate. That's perfect, right? Okay, all of that was just to find the polar form of this complex number. This should all be pretty familiar to you because we've been doing this for quite a while in trig. We started doing it in Algebra 2, but it's been a while and we've jammed a whole bunch of other stuff in your brain since we've done this a lot. So that's why I reviewed it in careful order. Okay, so here was when we used Pythagorean. This was step 1. We used Pythagorean to solve for x, and then here is where we used tangent to solve for the angle. All right, so those are our first 2 steps, and that's what we got. Hallelujah. Now I'm going to take this to the next page, and we'll start actually finding the roots. So it is 7.21 cis 33.69 degrees. Okay, there it is, our cute little angle. Now what we do, let's remember how we do this. To take the roots, we take, first thing we do here, I'm going to call it step 3 because we had 1 and 2 on the other page. We take the root of the hypotenuse. Now in this case, we want to take a 4th root, right? And if you look on your calculator, there we want to do this, right? We want to take the hypotenuse and find the 4th root of it. But there's no 4th root button on your calculator. So instead, we have to use the button that looks like this. It's a custom root button. And what we do is we enter 4. Then we enter this button. I'm writing it again. Then we enter 7.21. The way our calculator understands that is it says, okay, the first one, that's the x value, and then this is the function we want to use, and then the one that comes after is y. So the calculator will plug this in for x and this in for y, which is exactly what we wanted, right? We wanted the 4th root of our hypotenuse, which is 7.21. When we do that, we will find out that the 4th root is, and I'm going to write it here, the 4th root of 7.21, after we calculate it, will equal 1.64. Okay? So that's our first part of our answer. That's taking the root of the hypotenuse. And then, okay, so this is how we did that. We're finding 4th root, so that's why there's a 4 there. The 4th step is we take the root of the angle, and that's way easier. We take the angle and we divide it by, in this case, 4. Right? So it's 33.69 divided by 4, and that equals 8.42. Okay, now we know enough to be dangerous. I'm going to take this number and this number to the next page, and that is going to give me my first root. And this is how I write it. 1.64 cis 8.42 degrees. That's my first root. Okay? So I'm going to write first. Now, for the additional roots, what we do is we take 360 and we divide it by the number of roots we're finding, in this case 4. That gives us 90-degree increments. We're going to add 90 to this number in order to get the other 4 roots. This number will stay the same, so I'm going to copy it. The hypotenuse stays the same. The angle will go up. We'll have 4 angles or 4 roots before we get to 360. And I'll show you what I mean. I'm going to start adding 90 to this. It will be 98.42 degrees. Now I add 90 again, and it will be, let's see, 188.42 degrees. And then I'll add 90 again, and that's what, 278.42. If I added 90 one more time, I would be at 368. I would be too high, wouldn't I? I'd be over 360 degrees. So all of your roots should fit in within one circle of our 360 degrees. So this is our answer, 3rd. I did that wrong, this is 4th. So this is the answer. It's a big answer, isn't it? Again, what's hard about this compared to the previous problems we've done on this topic is just that these numbers don't work out as evenly as the old ones. Okay, let's try one more of these and then we will be done. There's only 2 examples in this lesson. This one will be pretty much exactly the same as this one that we did. The only difference is that our triangle is not going to be a first quadrant, so we're going to have to do a little more work to adjust there. But that's old news. All of these notes and instructions will be the same. I just wanted to write this out. We divide 360 by the number of roots. We get a number, and then we add that number for each additional root, each additional angle. I guess that's another way of saying it. All right, like I've said 100 times, it's so hard to say in words what the numbers are doing. It's so much easier to see the numbers just jump around. Okay, that's right. All right, let's try another one. Ready? Find 5 fifth roots of minus 17 minus 14i. Okay, we know that this is the rectangular form. We want to change this into polar form with the cis thing. This will be the hypotenuse and this will be the angle. It may or may not be equal to theta. It just depends if we have to adjust. We start by drawing the triangle. I see a minus and a minus, and that tells me this is a 3rd quadrant angle, right? Down where all the negatives live. So I'm going to draw that quadrant. And I know that, here, I'll extend it just a little. These are the real numbers on this x-axis. These are the imaginaries. That helps me get my bearings. I'm going to go 17 this way. I'm going to call it there. And then I'm going to go 14. I'll just call it there. The beauty of this is it does not have to be precise. I'll put a dot where my 2 numbers intersect. I'll draw the hypotenuse back to the origin. And then I'll connect my triangle up to the horizontal axis. We always connect to the horizontal. Draw a little box in there. Now, how long are my sides? This one is 17. I don't have to worry about the minus signs at all. And this side is 14. Now, this is my hypotenuse, and this is my angle. Now I can see, because my real axis is, or my axis is here, and we always measure the angle going from here around, right? Once I get my theta, I am gonna have to adjust it this time. Last time it was a first quadrant angle, so we didn't have to adjust. This time we do. So let's go ahead and work on converting to polar coordinates. First is our hypotenuse. This is step 1. That will be the square root of, 17 squared plus 14 squared. You have my permission to run that through your calculator. You don't have to do any of that by hand. Pause me and do it right now, and then come back. I hope that what you got is 22.02 as the length of this hypotenuse. So we can put that right up here. Okay, and now we have to find the angle, and that will start by finding the tangent. We'll use tangent of theta equals opposite over adjacent, 14 over 17. We use the calculator to solve for theta. You can use different letters. I love to use theta as my mystery angle. You can use X. For some reason in my notes from last year, I kept using A, an uppercase A. I don't know why, but it doesn't matter. So if you see something different in the book, don't let that throw you off. It can be theta, it can be X, it can be A. It's whatever you want it to be. Okay, so you use the calculator, right? 14 divided by 7 equals second tangent of -1, and we will get an angle of 39.47. That is this angle. It's just that much. It's the part in our triangle. We need to be able to measure it like this, don't we? So what we have to do is we have to add 180. So that when people look at our angle, they'll go all the way around to this line. That's what we want them to do. So this becomes 0.479. 219.47 degrees. Okay, we're finding fifth roots. So, here, I'm going to draw a little division here and reclaim this turf. For our third step, we will find the fifth root of 22.02. Again, calculator, we use that X root of Y button, like I showed you before. We'll take the fifth root of 22.02 and we will get 1.86. So that's going to be the first number in our roots. And then we will take the angle, 219.47. We'll divide that by 5 to get the angle of our first root. Again, you can use the calculator for this. It's 43.89. And then we'll take 360 divided by 5. That equals 72. Yes. Degrees. Okay, so our first root will be 1.86 cis 43.89, and then we'll add 72 degrees to create each additional angle. I'm going to write those on the other side. It's this number, cis, this number, and then I start adding my 72s. So here we go. My first root will be 1.86 cis 43.89. Those were the numbers I had on the last page. whoops, 8, 9 degrees. Then we're gonna have 5 more roots, right? The hypotenuse always stays the same. And then when we took 360 and divided it by 5, that number is what we add to this, and that number was 72. So this is what, 115. I'm just adding 72 in my head each time. This would be 187.89, 72, 259. And then 72 one more time will be 331.89. Okay, this is our answer. Those are the 5 fifth roots of that polar number we created way back at the beginning. Remember, these are all the hypotenuses, and these are all the angles that you can use. All right. This calculation is a little weird because why would you want to do this? We're not really covering that, are we? Which is always a good sign that someday in your future math skills, there will be an explanation as to why you might want to do this. But just understanding how to make this calculation, all of the different steps and details, is a fabulous head start on doing that. Okay, that's the end of lesson 95, straight and to the point. Thank you. Goodbye.